All right, next up is 5. It says to compute the improper integral of the function 1 over the quantity 1 plus x squared plus y squared squared. And our bounds here, x goes from 0 to infinity and y as well from 0 to infinity. And we're asked to compute this by first converting it to polar coordinates. All right, so here is my integral, and off to the right here is our region of integration. So we're essentially thinking about this surface defined by our function living over the entire first quadrant, okay? And so we're going to find the volume of the region bounded by our surface and above the first quadrant, okay? So I guess in terms of polar coordinates, how do I describe the first quadrant? Well, if I think about fixing a theta first, that's going to describe a line through the origin. So here's say a fixed theta. And r is going to vary from where to where. Well, along this ray, the low end for r would be 0. And then since this is an infinite region, r here is just going to approach infinity. Okay, and then we're going to let rays like this sweep from 0 up to pi over 2, right? So for the theta bounds there, theta is going to go from 0 to pi over 2. Okay, so that's first thing. So we can go ahead and set this up now as the integral from 0 to pi over 2, and then the integral from 0 to infinity. And our dx dy, that's just our dA. And so in polar, we're going to have r dr d theta. And then we're dividing here by 1 plus, and x squared plus y squared is r squared in polar, and then that quantity is squared. All right. So here we are. Couple comments now. One, again, our integrand is independent of theta. So when it comes to this r integral, it's constant with respect to theta, so you can think about it coming out in front, and then it's going to be multiplying the integral from just 0 to pi over 2 for theta, and that's just going to give us pi over 2. So all in all, that's really going to say, and I'll put that pi over 2 out in front, this is pi over 2 times our integral from 0 to infinity of r dr over 1 plus r squared quantity squared. All right, so it's a little bit nicer. As far as computing this integral now, substitution is going to be the way to go, because if you notice the derivative of 1 plus r squared is 2r, and so r dr up there is going to be du over 2. Okay, so now we're going to get pi over 2. The r dr would become du over 2. We're dividing that then by 1 plus r squared. Well, that's just u, and that's squared. And then let's change the limits as well. So when r is 0, u would just equal 1. And as r approaches infinity, 1 plus r squared would also approach infinity. So I'm going to get infinity there. All right, so this is pretty good. I'll put that 1/2 there out front, so I'm going to get a pi over 4. The integral of 1 over u squared is minus 1 over u. And now if I take the limit as we let u approach infinity, in 1 over u, that's going to approach 0. And then if I plug in 1, I'm going to get a negative 1. So all in all there, we get 0 minus a negative 1. So in fact, our improper integral is equal to pi over 4. Cool. All right, that's going to do it. Thanks.